Okay, good morning and welcome to the talk. I'm glad to present you Java technology on small IoT devices. I'm Jérôme Leroux from MicroEJ. MicroEJ is a software vendor that provides an operating system for embedded devices. This operating system includes a Java virtual machine. I'm the Edge project leader. So this is a well-known picture of the IoT, and what we want to show here is where is Java in these three verticals. So currently, in the IoT cloud platform, Java is everywhere in web services, websites, IoT protocol servers, and we also use Java to develop web services using Eclipse Edje. In the gateway and smart devices, we also have Java for to develop application over Linux and Java virtual machine. We can use OAGI frameworks. We also have clients of different kind of IoT protocols, such as MQTT with Paro or lightweight M2M clients. We also use Java-based IDE. But in more constrained devices, most of the development is done in C. So there is not many Java developer on constrained devices. Most of the time, we have a simple RTOS with a monolithic firmware and only one application on the device. And the IoT protocol stacks clients are developed in C. And Java is here only for the development with Eclipse CDT and Eclipse IDE. So why there is not so much Java in constrained devices? This is often developers say that Java is too big, it's too slow, too complex. Many developers in embedded constrained devices don't know object-oriented programming. They develop in C and sometimes in C++. Java is not secure. There are several issues on Java on PC, security issues on PC with Java. They don't need a dynamic loading on the embedded constrained devices. We don't want to download dynamically application or services. If we want to, we may want to upload all the firmware, but not only a subpart of the firmware. And on some devices, we have a Linux. So Linux provides many services, and we may not need a Java virtual machine. So let's debunk some myths about Java. About the size. Size can be controlled. You can choose and pick up only the classes that your application needs, and even the methods, and don't pick all the Java libraries on your device. Linux cannot run everywhere. To run Linux needs a MMU, and on Cortex-M or microcontroller, there is no MMU. There are some kind of Linux that run on microcontrollers, such as MicroC Linux, but it's not really a Linux because it doesn't provide sandboxing of the application. All the application runs on the same process. A virtual machine can provide sandboxing even without MMU. So we can have application sandboxing on a microcontroller. So currently, developers say that they don't need dynamic loading, but if we can provide us this kind of feature, they may want to upload only a subpart of their firmware to limit the the bandwidth consumption. And this dynamic loading is safe because Java includes a bytecode verifier, and so the bytecode that is downloaded on a device is safe. Java includes a garbage collector that permits to do dynamic allocation. Often in constrained devices, we don't do dynamic allocation because we don't want fragmentation of the memory. With Java, we can do dynamic allocation and defragment the memory, compact the memory to avoid fragmentation. Some other advantages of Java. So Java is an object-oriented language, and you can build service-oriented architecture with Java, with the reflection, class for name, etc. Java API are well defined. On embedded constraint devices, there are many different API. Each RTOS comes with its own API to manage threads or tasks and synchronization. And Java define a generic API for this kind of stuff, for the threads, the input and outputs, collection, network, and security. The Java technology is a huge technology, and there are many Java developers available, and training libraries, open source or closed libraries. So now let's talk about the Edge project and MicroEJ. So MicroEJ is involved in the Edge project, and the objective of the Edge project is to provide Java library for embedded constraint devices. Its objective is to provide a library for sensors or actuators. So the initial focus of Edge is to define a hardware abstraction layer with 3 different services: a peripheral manager that is in charge of listing the devices, the peripheral available on the devices. Controller communication interface management to use field bus communication, such as serial communication, I2C, SPI. We also provide digital and analog input and outputs. But Edge is also about defining a common API for all the devices. So we want to define a minimum execution environment provided for all Edge-compatible devices. This is the intersection between Java SE embedded, Android, MicroEJ, and this is what we call EDC, the Edge device configuration. So this library, this API, includes core Java long packages, Java I/O, and also other classes. So how we want to define this API? First, we are looking to what our customer needs, and also what we try to do is to port the different Eclipse open source libraries on EDC. So, for example, we have port Eclipse Power Java on EDC, Eclipse Lesson, Californium. And we are looking also to other API and available on the market, Android Things, OpenJDK, Device I/O, and Cura. How about MicroEJ? As I said before, we're a software vendor. We provide an operating system for embedded constrained devices. We have an expertise in embedded devices and virtualization. And we have partnership with silicon vendors, embedded software and hardware providers. we have offices in Germany, France, and in the US. Here is a list of the partner of MicroEJ. So there are hardware, silicon vendors, partners, software vendors, and IoT cloud platforms partners. This picture shows the market we target at MicroEJ. So basically, we target all the microcontrollers that cannot run Linux or Android. So the very small devices without an MMU. Here is an example of what we can do with MicroEJ. Here we have a customer that have a wearable, a smartwatch that uses Android Wear. This device includes a very big microprocessor, Cortex-A. It takes more than 35 seconds to boot. You need to recharge the battery every day. And the software is written in Java. With MicroEJ, we can have the same kind of capabilities, but on a very smaller device. So we can use Cortex M4, and the system boots in a few milliseconds. We reduce the battery consumption, and you need to recharge only every 2 or 3 weeks. So the interest of MicroEJ is to reduce the bills of materials and to reduce the power consumption. So here are the products provided by MicroEJ. So we have an SDK. It's based on Eclipse, and it contains tools and libraries to port our operating system on your device. We also provide an application store that is available on the internet, and you can deploy your application on the store, and then the devices can download the application from this application store. And we also provide MicroEJ Studio. This is an Eclipse-based IDE that can be used to develop application. So this is a free tool. So what type of products you can build with MicroEJ? This is an example of product called SOWI that was produced by EDF. This is a French electricity producer. This is a remote controller for home automation, and it runs on a Cortex M4 with only 1 megabyte of RAM and 4 megabytes of flash. It includes several Eclipse IoT technologies. So we have the PAO client, Java implementation of PAO on this device. We also have Californium and some part of Leshan client. We also use Edge for the sensors. So let's see this in action. I have two demos. One on a video that shows MicroEJ and Eclipse IoT Java technology running on a Cortex M7 from ST with a lightweight M2M client connected to Leshan server, and we can download dynamically some services on this device. So here we have the Cortex M7 board with a MicroEJ OS running. This board drives a washing machine, and it can drive also the lights using Z-Wave protocol. So here, the tablet is connected to a relation server. So the demo, first we install a new service on the OS. This is a lightweight monitoring client. So we start this service, and then we can you can see on the relation server the list of the services available on the platform. So, for example, we can start or stop application. Here we have started a simple application that displays some information about the OS. We can stop it directly from the relation server. Here we start the washing machine application. So we can start a washing machine cycle and stop it. And if we start the Z-Wave service from the relation server, then when we start a new washing machine cycle, the lights are turned on. So here in this demo, we have a Californium client embedded on the device. And another demo I'll try to show you. Okay. So here, this is a Cortex M4 board from NXP. So currently, it only shows the weather. It is connected to the internet through my PC, and we can download application from this to this device from an Android companion. So here, from my Android mobile phone, I can download application on the device. And start it. So this is a simple calculator. Well, I can stop it and install it. So the mobile phone is connected to our application store. Download the application on the mobile phone and then upload it on the device. So we can install other kind of application. A small game. So with this kind of technology, we can upload different kind of services. We also have another demo, but it doesn't work here because I have connectivity issues. That we can download a MQTT agent client dynamically on the board and provide the MQTT connectivity to the board. Thank you for your attention. There are some links to the Edge project and the MicroEJ developer website. Do you have any questions? Yeah. No, we are using the relation lightweight interim client. So we are using Californium, and we integrate it in our operating system. It's a Java client.
So Edge project Eclipse is the same as the commercialized product from MicroEJ company?
We plan to have several ports of Edge we have a reference implementation on MicroEJ, but we plan we are developing a new reference implementation on a Raspberry Pi using Oracle virtual machine, and we plan also to run Edge on PC for simulation. So this is not related directly to MicroEJ. You can run Edge over any kind of virtual machine.